So thank you for inviting us in to give you this presentation on what we jokingly but also honestly call extreme BPMN modeling. We consider it a bit of a breakthrough for designing BPMN models, mostly because it leverages the model data itself that is in the associated BPMN XML, or in an alternative form, which would be a semantically equivalent one as expressed in ontological language, such as the web ontology language, or OWL, from the W3C. So go ahead. What you're about to see is undoubtedly going to seem rather geeky. I mean, in this audience, that should go well. But it is not solely a tool demo, and it's not going to have quite the polish that some of the other tool demos have had, and those that are still to come. It is also not solely a theoretical examination of BPMN modeling, because we are actually practicing some of these principles in the projects we're working on. The concepts you will see explored here are the results of the research that Mohamed and I have done, both individually and collectively over the last several years. The tool portion of this presentation uses an ontology-based engine, which consists of three things. One, a triple store for housing the data in a resource description framework, or RDF form. A second is a Sparkle query engine, which is the query language for semantic data. And it uses the Jena API to manipulate the RDF OWL information that's stored in the ontological form. And third, a BPMN XML to OWL generator, so that it maps directly modeled concepts in the XML to their equivalent OWL form. Lacking only a GUI, we still have to run these commands from the queries from the command line, so it's going to look a little bit raw. But mostly we're going to show you that what is possible with the technology as opposed to how it might ultimately look when it's fully implemented. The approaches, as I said, we have been using in part at either the Department of Defense within the Deputy Chief Management Office, or currently with the Process Modeling Design Center, which is a center of excellence within the Department of Veterans Affairs. So as innovative as BPMN is, until 2.0 came out, it really was just little better than drawing boxes and arrows. More important than the expansion of the notational set with newly describable operational behaviors, it was the move to serialize it into XML that we consider to be the truly groundbreaking moment. Especially when we consider that we can use the information in there to understand it within a very structured way, which is defined by the spec using the UML-based meta model or meta object facility, or MOF, defined for the spec, which is, as you can see, rather complicated. To give you a sense of perspective, I believe an unofficial meta model for 1.2 fit on one page. So it's an order of magnitude jump in terms of complexity. This opens the door for modeling conventions and related attribution schemes to be applied to the model such that they can be leveraged as data, not just diagrams, for uses that only now are possible in a standards-based and tool-agnostic way, which is important if you're in a heterogeneous tooling environment where you have to take input from a variety of sources and find it consolidated into a single repository for some purpose, such as enterprise architecture and associated uses. You have to have, as a basis for this, some kind of guidance, whether it be the Department of Defense's primitives and patterns for use with the analytic conformance class, which is what I've been teaching at the DCMO, or the methods and styles for similar purposes, which are available through the channels that use Bruce Silver's guidance in this matter and the book that he wrote on it. We have to do this along with an attribution scheme to ensure that the right kind of data goes in the right place, such that we can create or ensure the creation of correct and intercomparable models that whose semantic meaning can be accurately parsed, understood, and analyzed. This approach can now also incorporate the use of concepts more intended for the Common Execution Conformance class, such as item definition, interface, correlation, and performer, to correctly incorporate those concepts within the usage of the BPMN schematic elements. Because of its abstract nature and hierarchical structure, XML can be a challenging format for containing and analyzing model information, particularly when many models and instances of models are involved. It is proposed here that an ontological form using OWL would be better than XML straight up for such a set of purposes. Representing model data in ontological form is achieved through the use of the W3 standards for RDF and OWL for the data itself, and for Sparkle for querying that data. And all of these things can extend the richness of the semantic concepts of BPMN beyond what the XML itself can natively support. An ontology is a formal, explicit description of a domain, for those who are not familiar with it, that contains these concepts. The concepts are classes. You might think of them as entity types. Concept instances, which are the actual realized occurrences of those concepts. No, go back. And data properties of those concepts would be similar to what you think of as attributes. Object properties among concepts, and these would be the relationships between objects, which are understood when the instances exist in relation to each other. Data ranges on either types of these properties, and restrictions on concept instances as they occur. So this extends what is well beyond what is currently possible with strictly relational data stored in something like a relational database and subject to SQL types of queries. Okay. So a BPMN model represented in ontological form has several advantages over the XML form. You can retrieve information about a BPMN model as instances from a repository of models in a way that's much easier because the information is not behind a proprietary tool interface. So we recognize that a lot of what we're about to show you is a shot across the bow to the tooling market, but we believe that this is still the way to go. Second, linking such information between different BPMN models and instances is more easily implemented because all of the data can now be reside in the same form and the same data store. And third, and this is key, semantic languages allow us to leverage inferencing across data concepts in a way that's unique to semantic technologies, and therefore it gives us an edge over traditional query types, query approaches to data, such as those in a relational database, because less has to be known in the construction of the query than would otherwise be known in the case of a structured query using something like SQL. Taken together, all of these mean that accessing model data can be smarter, be done by smarter means, and the data in the semantic form is represented in what we call an RDF triple. So it has a subject and a predicate and an object. Each one of those has a separate URI, which constitutes an instance in the storage. Since BPMN models can now be represented as data, the models can now be effectively integrated within parent architectures. No, go back. So, no. This one. Sorry. So the understanding of the model can exist within the context of parent architecture. So you see up here we have an ontology for BPMN, and we show how it maps to the central concepts within the Department of Defense Architecture Framework, or DODAF. So this mapping has been worked out for the purposes of incorporating BPMN models generated from the XML itself into the larger construct that we called a DODAF architecture. And this uses the mapping to what is called the DODAF metamodel, or DM2. And those are built around 4 core concepts: capability, activity, resource, and performer. So in such a model, we can create what is called an OV, or operational view, type 6C diagram, which is a fancy way of saying a BPMN model. It captures the operational event trace of a business process. For example, and all of the concepts in such a model map to things inside here. For example, in a BPMN model, a message flow conveys a message, which is an informational type of resource that it's also known as information exchange element within the context of the architecture. So a BPMN model that includes a pool in which a core business process is detailed out can be said to have a set of abstract interfaces with respect to other participants in the process. And when it's defined as an OV6E type of model, we get something like this. And this may be familiar to those of you who know the BPMN 2.0 by example document from the OMG with respect to the BPMN 2.0 spec. This is the initial version in which we have the collaboration called out. And this is basically a mediated, there's no mediation here between participants. Now let us introduce the concept of the system pool in there. And we'll see that the system pool, initially represented as a black box, calls out these mediation points as basically the interfaces. So these would be the message flows from one thing to the other, representing concrete interfaces, no longer abstract interfaces. These concrete interfaces would be GUIs, so human to machine interfaces or system to system interfaces. Once isolated, we can then expand it out, and notice we collapse all the other pools, and now we have in the center, which essentially is the system design for the trouble ticket operation that supported the fielding of a trouble ticket with respect to all these other participants in the collaboration. So this would be what we would call a system view, or a type 10C or SV10C type of diagram in DODAP. And the advantage of this approach is simply this. We don't deal with model round tripping, we deal with model preservation, because you notice that the predecessor model hasn't gone anywhere. It has simply been extended by introducing the mediation concept of the system pool. And now the system pool coexists along with the other collaboration within the architectural context, and we haven't lost anything, we've simply extended something. So within the management of the process model as architectural information, that is our goal. To be able to preserve what we had before, but yet extend it to capture the system level view of the operational semantics of the thing that's to automate that business process. So BPMN is now rich enough to be nearly equivalent to a visual programming language, with the model defining the orchestration of complex operations implemented via abstractions. This would be the task types that are implemented via invoked components. Realized as services, the set of relationships between components in the BPMN model represent a new type of services modeling. And services modeling was recently identified at the BPM 2012 conference by Stephen White as one of the two critical areas for future research and development of BPMN, the other one being case management. Unfortunately, a BPMN model is not able to naturally convey important aspects of its implementation, such as the wiring among deployed concepts and components. With its natural alignment with SOA, though, BPMN concepts can be mapped to and thus be used to derive things like a service component architecture concepts, which is what you see here. And SCA is a standard from OASIS. You could use the same approach to mapping to something like SOML, which is the SOA modeling language from OMG, but SOML is more verbose in its diagramming than either BPMN or SCA. To make this possible, the XML must be enriched with interface information irrespective of whether the BPMN model is executable. And this is a key distinction from what probably was otherwise intended in the way the spec was written. So we're essentially taking execution concepts and leveraging them outside of an execution context for our own purposes. This enrichment follows a modeling approach and attribution scheme that embeds the relevant information into the XML by way of a modeling tool, if it supports all that, and not many do, but fortunately you've seen some of those that do presented here today, or by directly editing in with an XML editor. Though there is no official diagram scheme for SCA, there are visual representations for indicating the wiring of the types of services, whether they be request, response, synchronous or asynchronous, and publish, subscribe relationships. The derivation of the SCA composite XML and the diagram of said same is essentially doable, given that it's all in data form. We should just be able to transform one representation into another. That is still under development, by the way. Here we have a candidate SCA composite rendering using my own stencil from what you saw before. Yeah. And you'll notice that essentially everything is essentially called out, but the advantage of this representation is it shows me the integration between components and how they are wired together. Now, yes, some of the major vendors, particularly the top three, have some means of doing this now, but with respect, I believe they cheat because they do so by their own native and proprietary means of associating these relationships. What we're attempting to do here is create this understanding directly from the BPMN semantics as properly understood and as represented as data in the BPMN XML. So what you see here are the named operations for the model tasks represented as interfaces into or out of the construct. Events correspond to those interfaces as well as to the messaging that goes into and out of the construct. Components that are not implemented explicitly with interfaces, which is an actual concept in the BPMN XML, are assumed to be within the construct. So for example, these service components weren't defined with a service interface, so the interpretation by the logic we're proposing means that they are automatically assumed inside the composite. And what that means is that they're deployed and released as part of a single thing. Externally called services have to have interfaces so we know how to invoke them. The structure of a BPMN model is better analyzed after the XML is converted into semantic data. Using the previous model, the enriched XML is transformed into OWL using an automated tool that transforms the XML into OWL, using an automated tool to do so. The new form can directly support different types of queries and support different types of purposes for those queries. For example, identifying services used in a BPMN model terms of the abstract types that are actually doing that, or rather the task types that are actually invoking those concepts, or the events that associate with them. This will be important in a context of a SOA framework where we want to be able to insert the BPMN model into a larger governing context for services modeling. Second, we can determine structural relationships of the model, such as whether things are correctly sequenced, and if they're following guidance with things like gateway usage. We could test for that, and why that is important is if we want to determine enforcement of the appropriate conformance to those principles. This gets around what the tooling today, some of which you've already seen, does natively within their own tool. This is a means to do it in a standards-based way that's tool independent. And third, representing key architectural concepts in spec-conforming ways allows us to talk about how the BPMN model can be accurately inserted into larger architectures. So if we understand the meaning of something correctly, we can absorb that into the larger constructs of the enterprise architecture, and it will be consistent in its understanding. So you see here, it returns the performers that have been identified and inserted into the BPMN model as performer information for those activities. This query returns that result set. All right? And that's using performer in the BPMN specific way that is to be understood, which is a compositional element of a task. However, in many architectural contexts, the swim lane as a role is to be considered a proxy for performer, and you can query in that regard as well, and you can get these activities. However, that query requires certain adjustments be made because in that context, there are only certain task types that can be returned. So we have to account for a more complicated query set in that regard. However, if we choose to use the role, the swim lane in the BPMN model, as the representation of our architectural concept, we can do so. And these different treatments are not compatible with each other. You have to do one or the other if you're going to incorporate all this information into an enterprise architecture. So go on to the next one. All right, so the next one is about the structure. So we're going to query for what is it that preceded the activity performing activity G? And so it returns this result set, which is an event, a throw message event, send message F. So we can query for structure in this regard. And we can also query for conformance to modeling convention, which is we want to say all gateways can only have diverging or merging behavior, but not both. So here we're testing on the presence of diverging behavior to isolate whether or not that's been used and followed within the model. And what it returns here is the three gateway types that you saw in the model to indicate that, yes, they followed the rules that were attached to this for defining what was diverging, which was that you had multiple outgoing flows versus one incoming flow. And we found this a more reliable way of testing for it than using the actual gateway direction attribute type. So a BPMN model data that includes item definition can now support assessments of data usage from the perspective of the related elements of the model itself, especially when represented in ontological form. Here the concept of veteran, and you see veteran represented as the data object here, or at least visualized that way, is present in the data object, and it has been defined via data item definition, and it refers to a complex schema type with certain elements, all of which are defined in a namespace. Determining from a set of BPMN models which ones represent the processing of specific types of data, such as veteran data, is best achieved if the model data is an OWL and stored in some kind of repository that you can query. In this form, the ontological mappings therein support the crosswalk of the concept to the actual model instances. So go ahead and launch the next one. So as you see this crosswalk, we're going to define the namespace, and I'm going to reference the CMOF or complete MOF for defining that in terms of veteran, so that you see everything is relating back to that. Then we're going to see that we have a file containing the schema itself and how it aligns with that namespace, and here are the individual elements that comprise the complex schema type. And then you'll see in the next file that pops up, you will see the actual instances of the model, of the actual process instances, and then, again, how we can cross-reference them. Whereas veteran, we know goes to data item 1, which is item definition, and data item 1 is referenced as data input within a specific activity within the model. So we've basically taken the BPMN model data and found our way back to a data understanding as related by schema. If we do this richly enough and broadly enough, we can in effect create a data model for the entire set of business processes and treat it and analyze it as such. So a BPM model, when implemented typically on a BPMS platform of some kind, usually gives rise to process instances and associated activity instances that represent the individual transactions moving through the process sequence. Accessing and reporting this information is generally the province of business activity monitoring, or BAM tools, supplemented perhaps with business intelligence type of reporting. BAM in-flight transactional data can be paired up with persisted transactional data as part of business intelligence data reporting capability, usually visualized as some kind of dashboard type or GUI. However, process instance data stored along with model data as RDF triples provides a standards-based mean for implementing this same set of capabilities that you otherwise get with BAM or BI tools, and to do so without the associated vendor tool lock-in. So a BPMN model in ontological form can include data for actual process instances as well as data about the model structure itself. Here are the 10 process instances are indicated by the listing of 10 instances for the veteran complex type. Okay, that was the BAM structure. So you can see how BAM is related to transactional data and all represented through some kind of dashboard. So what we're essentially saying is if when we change the structure of this from relying on the native component within the BPMS suite to dealing with it in semantic form, all of this can be achieved by standards-based means and in a platform-agnostic type of way. So here are some queries to showcase this capability. So we've got the 10 instances that we created as if we were a BPMS engine executing the model you saw earlier for the veteran treatment. And so we're going to call that out. And you'll notice up here, we have a number of 3959 and then another number of 6744. The 3959 represents the count of actual semantic nodes that we're checking in the query. The number of 6744 actually represents the inferred number that we would be checking if we actually had to do this as a SQL query, in which we have to do a very structured and hard kind of querying against the data. So you can see that semantic form allows us to get away with a lot less. Here are the 10 instances as they are returned. Now this is only lacking a GUI to make this look like any kind of BAM dashboard, but that's essentially what it just did. And it captured it as transactional data that is the result of something moving through the system. This test is if we wanted to find the veterans who were female, and we can test and recover that information in a very specific way. Again, this is tying all of the BPMN semantics with the schema understanding and the instances all rounded up within a semantic form. Okay. And then the third query, we'll get to it in a moment, deals with trying to determine how many veterans were born after January 1st, 1980. And that will show up here. And this also happens to be based upon the model's BPMN semantics, the amount of outbound paths that occurred from the exclusive XOR gateway that went to the add record service task type. Okay, so closing, 2 minutes, on possibilities and current limitations. Go ahead. So we find that BPMN modeling with governing architectures can be done now without vendor lock-in, and we think that's a powerful statement to make. And it allows us to work within a very heterogeneous environment. Tooling that toggles between the BPMN and translated alternative forms, such as the SCA one, can support model-driven engineering, and the results will be usable for software development projects. And then finally, BAM or BI type of reporting that is platform agnostic and provides an alternative to proprietary systems based on traditional ETL types of models can give way to something that's much richer. And these are essentially the three use cases that we see for BPMN model information understood in semantic form. The limitations, the lack of a commonly accepted ontology for BPMN 2.0. So that's still out there. It's not something that everybody agrees on. But I think the larger point is it doesn't matter which one you use as long as you have one that will map to the BPMN XML through the semantic concepts that are therein. Little tooling that supports full capture of the BPMN semantic concepts. So you've seen a lot of ones that actually manage to do that here today, but my sense is that in the larger market, this is still not an achieved result. And the limitations of XML schema and the ambiguity in the spec itself make for interchange problems, which also limit to what we can do with this. But at the same time, it may actually give us a way out because we can sort of disambiguate, if there is such a word, some of this stuff by moving it into a common semantic form. So that's it. Thank you very much for listening to us, and may our BPM modeling be extreme.